flying is not very safe per se, but because there's these processes and these checklists that they need to do, it's become very, very safe to fly. Mining is very similar. Having said this, we're not really happy with the performance that we have. We have a very clear objective, and what we aim for is zero harm. And what this means is we want to have 0 accidents every day, every month, every year. Some months since 2000, we have achieved this 0 harm, but we have not been able to sustain this. Now, the big question that we're really trying to answer here is, are we getting safer over time? And with the kind of variability that we have in our data, as you can see here, it's very hard to determine, are we getting safer or not? Especially when we have a safety team that is doing an amazing job, but you're seeing this kind of variability where one month you're having maybe 5 incidents, next month you're having 3. You're saying, hey, what I'm doing is working, and then next month you're having maybe 4 or 5 incidents as well. And even if we look at a yearly average, what we're seeing is also a lot of variability. So kind of like the conclusion to which we arrive depends a lot on the base year that we take. So if we look at 2024 and we compare ourselves versus 2023, we might say, hey, we're actually doing a little bit better. But if we compare ourselves versus 2022 or 2021, the conclusion might be, hey, we're actually doing a little bit worse. So how can we differentiate what true progress looks like? In addition to this, the way incident reporting works in mining, we have a naturally a data set that suffers from survivorship bias. And survivorship bias is this logical error where we only focus on events that survived a selection process. The classical example of this is during World War II, the statistical research group was trying to figure out where to armor planes, where to put armoring on planes. The initial thought was, let's put armoring where we see the bullet holes. But what Abraham Wald said, who was a mathematician part of this group, was we shouldn't be putting armoring where we see the bullet holes, but we should be putting armoring where we don't see the bullet holes. Because the assumption that we're following is that the distribution of bullet holes is the same both on planes that return from combat as with the ones that don't return. But in reality, what's going on is that the distribution is very different. The ones that are not coming back probably have bullet holes on those spots that we're not seeing, while the ones coming back have these bullet holes on different spots. So by armoring planes on the spots that there are no bullets, we should be able to increase the return rate. Now the question is, why does our data set suffer from survivorship bias? And the answer is that we only report accidents that happen, that occurred. We do not have the capability, and it is impossible to record every single maneuver that was successful. Why? Because of the scale at which we operate. We're operating 24/7, and we have so many, like the scale at which we operate is really, really big. So think of a whole truck is driving probably around 80,000 miles per year within the mine. And how do you define a maneuver? Is it 1 kilometer driven, 1 mile driven, 1 leg driven? What's the definition of a maneuver, and how do you define a successful maneuver? Even more so, which with haul trucks could be a little bit easier because they are digitized and we know by the second where they are located. But think about manual labor. Like we have a lot of people doing maintenance, for example. We don't know what they're doing every second. Are they tightening a bolt? Are they walking somewhere? And when in that moment occurs the accident, like we don't have that capability for doing that. It would be impossible to do so. And an additional factor is the human factor. Like at the levels we're right now, which is around 1 incident per month, how the people are feeling is very important. Are they getting distracted because they had a fight before leaving home? Are they getting distracted because they received bad feedback? Something happened in that specific moment that led them to get distracted. We can't measure that either. And that's an important factor in this case. That's why we need all these processes and procedures. So the combination of these two things of scale and the human factor is what is going to make our data set skewed. So as I said before, the key question to answer here is, are we getting safer over time? And to answer this question, we thought about 3 different ways of doing it. The first one would be to predict a risk by maneuver. The second one, predicting the incidents per month. And the third one, identifying the changes in distribution. So predicting risk by maneuver would be telling a whole truck mechanic, hey, you have a 20% probability of having an accident when you finish this maintenance, for example. While in theory it is very powerful, the reality is that it would be impossible to put into the operation. One, because we don't have the data to do that, as I mentioned. And the other one is because we would be sending thousands of alerts every day. And what would end up happening is if I tell a mechanic, hey, you have an 80% probability of being in an accident here, and that doesn't happen, what the mechanic is going to do is going to say, hey, this doesn't work, I'm not going to trust this. So the model wouldn't work and they wouldn't use it. And now, the next one would be predict incidents per month. This could be done. It's very easy to do. We have the data to do this, but the issue is that the insights that we would give the safety team would not be tangible. Like, what can I do to drive that down? Change the month? Well, we're in April. I can do nothing. Have less people? I can't, because if I have less people, I don't need production. So it can give this sense of false levers that you can give, when in reality it's not very actionable. And the more serious problem here is model degradation. If we see the model degrade over time, is that degradation due to the model degrading, or is it because we're improving in our safety metrics? And we would have to do further analysis to understand what is driving that model degradation. Now, the third approach, which is identify change in distribution, is estimating what's the underlying probability distribution of the incidents that we see. This is easy to implement. It directly answers the question that we're trying to answer here, because if we see a change in those parameters of the distribution, and we see, let's say, a Poisson with mean 1 shifting to a Poisson with mean 0.5, hey, we're doing well. The issue here is that we're assuming a simplified data generation process. So we're basically ignoring all those things that we could have that drive the number of accidents, and saying, hey, I'm going to ignore all of that, and I'm only going to try to model the number of accidents that we have right now. And what's the expectation of accidents, that range of accidents that I could see. And another issue that we have here is that it is retrospective in nature. With the other two, I could say, hey, for the next month, you're going to have 2, 3, or 5 accidents. With this one, what I need to do is wait until we close the month, and then I can tell you, hey, this is how you did, you were within expectation or not. So which way did we decide to go? Well, it's the Changepoint route. So what we're doing is we're trying to detect a shift in the data, and how we're interpreting this shift is that the underlying process is changing and that we're either doing better or worse. Now, there's a big assumption here that we have, and it is that the underlying conditions of the operations are stable. And the way we validate this is by working closely with our operations team and our safety team. So they tell us, hey, I had a higher number of people than usual on site, I had less people than usual. So if we see a change in the model, in the distribution, we can say, okay, we're seeing this change, but there was this other condition that might have affected this. Once we have that defined, there are really 3 questions that we're trying to answer. The first one is, what distribution governs the incidents? The second one is, are we seeing a change in the parameters? And this is really the fundamental question, because if we see a change in the parameters, it means we're getting better or we're getting worse. And the third one, which is especially important in this case, is how confident are we of the change that we're seeing? Because it's not the same that I tell you, I'm 20% sure that I'm seeing a change in the parameters of the distribution, than if I tell you we're 80% sure that I'm seeing a change in the distribution. Given these questions, we have 2 outputs that we generate. The first one is a forecast of the number of incidents. I'm going to cover this in the next slide. And the second one is a monthly alert of probability of change. Right now it's monthly. We're pivoting into a weekly alert. And the advantage of moving into a weekly alert is that we can add some predictive capabilities to the model. Because by doing it monthly, what we're doing is finishing until the month closes, and then we say, hey, you did well or not. If we're doing it weekly, we can say, hey, the second week of the month, you had a higher than usual rate. You need to double down on your safety efforts and double down on your safety initiative. So we can bring that number down for the rest of the weeks. So the key question, are we getting safer over time? So our first approach was using a traditional change point analysis using a Poisson distribution and PELT, which is the algorithm used to detect and determine the number of change points that exist. And we had 2 distinct conclusions here. So if we look only on the standard output, which is the left column, we see only 1 change point at around observation 150. And that is, I think it's like October 2014. So we see this change in distribution, and we could say, hey, we're actually doing better than 2014. But the way the safety team looks at this is they do the year to date. So they would add up all the accidents that occurred from, let's say, January to April, and they would say, for example, on 2025, we're having 5 incidents, 2024, Oh, let's take that 2024 example. By May, for example, we had about 8 accidents. If we look at 2023, maybe we had 9. And they would say, hey, we're actually doing better. But according to our initial analysis, we're doing the same. But as we can see, there's a lot of variability still around the mean. So what we did was we took the Poisson distribution that we had and we accumulated it over time. So we started adding up for January only 1 Poisson distribution, for February 2 Poisson, for March 3 Poisson distributions, and like that until December, where we got to 12 Poisson distributions. And as we were adding up the Poisson distributions, we were able to determine this confidence interval and get like a 90% confidence interval. Say, hey, 90% of the cases we would expect to see the number of incidents around this number. The issue was that around this time, this is like July, we start seeing that it's going below that 90% threshold, that lower threshold. So the question was, am I getting safer? Because on one hand, I have my change point analysis telling me, hey, there's no change. But on the other one, I'm seeing that I'm below that threshold. And really, that's when we said, okay, this analysis is not enough, and I need to add a measure of uncertainty and how confident I am that I'm actually going to see a change in distribution over time. And this is when we pivoted to our Bayesian approach. So using a Markov chain Monte Carlo approach, we were able to assess how confident we were in observing this change point. And this is using RBIS. We decided to use RBIS because it was very simple to implement and quick to implement. So let me walk you through the graph here on the right. So the trend, the gray spots here is the actual data, what we were seeing. And the line here is the estimation of trend that RBIS is doing. These vertical black lines are the change points that we're identifying. And this part, the second chart, the one that says PR TCP, this is what we're interested in, because this is giving us a probability of observing a change in each specific point of time. And what we're seeing in 2024 is that this probability of change was like 1 or 2%. This is 20% for reference. So it was a very low probability of change. And then if we also look at the fourth chart here, the one that says SLP SGN, we can see what's the estimated slope of the trend. So if it's green, it means it's zero slope. If it's red, it means it's going up. And if it's blue, it means it's going down. In this case, what we see, it's mostly green. That's 98% mostly. So we're pretty confident that our incidents are flat month over month. And we're not seeing an increase. So the good news, the bad news is that we're not improving versus the previous year. The good news is that we're pretty flat and we're pretty stable in the number of accidents that we're seeing over time since probably the last like 6-7 years. Now you might be thinking, why is this relevant for me? Beyond, I hope you finding interesting. Probably you don't work in mining, you don't work in safety. How could this be applied to other industries and problems? And the issue, and this comes a little bit from my consulting background. I've been in multiple monthly review meetings, board meetings, where decision makers are looking at numbers and making decisions made based on point estimates. So they are looking at, for example, employee turnover and saying, hey, employee turnover went from 1.1 to 1.7. We need to do something about our retention strategy. They are looking at customer churn, seeing a decrease from, let's say, from 5 to 4.3%, and saying, hey, we're doing great. Well, we don't know. Or sales, probably, saying, hey, we're 5% below budget. We need to improve our sales efforts, and we need to change something in what we're doing. And while it could be true, we don't really know, because all of these processes incorporate some randomness in them. And the way we thought about this was, if we can use these Bayesian methods or change point analysis to quantify that randomness and say, hey, are we really seeing a change in this trend? This could be helpful. So what we think is probably a data science team is going to do a very robust analysis, but a business team is going to do a very simple analysis using point estimates. And this is where there could be value for other teams, other functions, other companies. So takeaways for communication, what we learned from this process. The first one, oh yeah, there it is. So the first one is to explain the concepts in a simple and easy to understand way. When we're explaining data science concepts to our stakeholder, which is usually a business user, we don't need them to be experts on all the details that we're doing, but they do need to get a good idea and a high level idea of what we're doing, how we're doing it, and why we're doing it. And the best way of doing that, in my experience, is simplifying the concept. So I could explain this saying like, hey, we're gonna assume that incident generation follows a stochastic process instead of a deterministic one, and probably nobody's going to understand that, unless you have kind of like a statistics or data science background. But they're not going to understand that. But if I can tell them, hey, imagine that incident generation is determined by flipping a coin, and the number of incidents that we're gonna have is gonna be determined by the number of heads that I see. If I'm flipping the coin every month, and 1 month in particular, I see a lower number of heads, it wouldn't make sense to say, oh, I did something right, because I'm flipping a coin to determine how many heads I'm seeing, how many incidents I'm seeing. But a smarter question would be, did somebody change that coin in that month? Am I seeing a different coin? Am I using a different coin in that month? And that's what we're trying to determine here. Did someone change this incident generation machine that we're seeing every month generating incidents? So explaining it in an easier way is going to make them buy into the solution and feel comfortable presenting to upper management. Now, related to this as well is start with simple solutions, even if they are not perfect, because once they generate buy-in in your initial solution, it's then easier to add complexity. And the context in which we started doing this project was we had a month where we had 5 incidents, and the previous month we were coming from 3 incidents. And during our monthly review, the CEO, rightly so, started questioning why that was the case. The safety team did an amazing job explaining why we went from 3 to 5 accidents. And this has a name, and it's called hindsight bias. We as humans are experts in figuring out the reasons to explain why something happened. We can connect the dots in any way we want to make a story make sense. So in that context, I said, hey, we shouldn't be, for the people, from a people perspective and a safety perspective, it's not okay. We should be having 0. But from a statistical perspective, what's the expectation? What's a reasonable number to expect every month given what we have seen in the past? So we thought, okay, should we go with this Bayesian analysis first? And we saw that it was going to take a little bit of time. So we said, okay, let's do Poisson estimation, maximum likelihood estimation, and see if there has been a change or not, how extreme that value is. So we decided to go with this first approach, very simple, and we said, hey, there is no difference here. We're within expectation. Only when we saw that the model was not helping us answer the question that we were trying to answer, which was when we went below that lower threshold, we said, okay, we need to change. We need to add complexity here. And that leads me to my final takeaway, and it is that complexity is really a means to an end. In our case, and I would say in most data science teams, our job is to help other teams make better decisions. We shouldn't be measuring ourselves by how complex our models are, by the error that we have, or by how nice they look. We should be measuring ourselves by if I'm helping my stakeholder and my client make better decisions. And that might be trading off between a very complex model and a simple model. And if the simple model is already helping me drive better decision making, I don't need to add more complexity, because the complexity should be added if I'm not answering the business question that I need to answer. That's what I had prepared for today. I think we still have some time. Yep.
We take some questions. Just curious, so when you're doing the monthly rate and I'm thinking back to the slide where you had the 4 different plots, and you started to get more confident by the end of that year, that you were really seeing no change. Are you pulling data forward from 2020, from the year prior for the first several months so that they're all kind of based on the same number of days? Because ultimately that process, right, is like, are you safer at any given point in time? We're kind of breaking it down into the increments that work well for thinking about it and talking about it. But But is it based on the same amount of data, or are you adding more data so that it's actually harder to change by the time you get to the end of the year?
So it's just the monthly data. So for example, by March, we're seeing March and the previous month, and we're trying to figure out if the rate in each month is the same or not. But it's not that I'm adding more data, but it's monthly data.
Okay, so you're not like you're not adding the n size of that model.
Yeah.
Not going up and up and up.
Exactly.
Okay.
Yeah. Yes.
When you were developing your methodology, you had the 3 different choices and the pros and cons were listed for each one. What was the reasoning around maybe picking 2 choices versus just the one? That way you can sort of like see both this this piece, but also see whether or not there's this predictive change too. Or would that sort of conflate one because you're already making changes in the other? I don't know
So,
if that makes sense.
let me see if I get it. So why did I decide to go with the changes instead of testing the other 2 as well?
Or picking, say like predict incidents per month alongside the other.
Okay. Yeah. So the first one, the predict risk by maneuver, we can't do it. Like it's impossible. We don't have enough data. It would be impossible to put into the operation. Incidents per month, really, it was from a conversation with a safety manager and figuring, okay, what do you really need? So a lot of, and I think it goes back to what they were saying in the panel. It's talking to your user, to your customer, let's say, and figuring out what are they trying to answer. Because I mean, yeah, I can give them a forecast of the number of accidents. What are they gonna do with that? Probably not much. But if I can tell them, hey, I'm seeing a change in the rate here, in your underlying rate, there's more value in that than just saying, hey, you're expecting between 1 and 2 incidents per month.
Okay.
Yes.
Within the context of international business, how did you see the ability to translate these models and the insights into insights that people were prepared to receive? For example, in the Mexican market versus the American market.
So actually, I would say they are like it will all depend on the openness. So usually, if you have buy-in at a high level, and that's usually what you want to find out, like you want a sponsor that's kind of like C-level executive. If you have that sponsor that can help you open doors, that shouldn't be a lot of difference. And also when you show the value that you can bring, and start usually from the need that the team have, they're going to be very open. So we started this in the US, and this is US data that we're showing. But when the corporate team, let's say, that oversees all countries, knew about this, they met with us and told us, okay, how is this working? What are you doing here? And when they understood what we're doing, they said, okay, this is actually very valuable because that's a question that we have and we cannot answer. So what I would say is, as long as you start working from the needs of your customer and develop a solution that answers that question and that need, it should be fine. Like you're not gonna find a lot of differences between countries, I would say. Follow up?
Yeah. So, okay. Now, understanding the customer profile and seeing that it doesn't change that much between countries, I want to transition this into another question, which is, if you have this information specifically about a group of mines, is there a translation in terms of the procedures they're following in mines here into mines in other countries? And how do the regulations translate along with the insights?
So we haven't looked at the comparing incident rates. I don't think that I wouldn't feel comfortable comparing the rates. Like that's something we do and we compare and benchmark constantly to figure out, okay, this is our safest site and this is what we should be aiming for. But there are a lot of things about culture in each country that I wouldn't feel comfortable like comparing one to the other and saying, oh, this one is doing significantly better because of this model. Yeah. I think you had a question?
Yes, I guess it's just I wonder how you approach any kind of, this is not a data question, but like an industry question where it's obvious that the ideal number of accidents or errors or mistakes in analysis or whatever is 0, and there has been a trend of getting safer where it's going down a little bit each year, but you're getting closer to 0, and the pressure to get 5% better than last year never goes away, I guess. So how do you approach openly the idea that, well, you know, getting rid of the last 1 accident per year is going to cost way more than it's worth or something? How do you talk about that?
It's a great question. So I think on one side, like as data science team, we're not really doing the work. We're providing the insights, and we're helping them figure out, hey, what you're doing works or doesn't work. On the other hand, what I would say is a culture of the company. And the way we say it, and the way I've heard like C-level executives say it is, everything that leads to safer operations, it's really an investment in our people. It's not an expense. So whatever we can do to make this safer and have our people have a healthier life, it's worth it. And that's kind of like the mindset in which we operate. I think we're still far from that 1 accident. Probably in terms of fatalities, we're way beyond that because we rarely have fatalities. Like in all of the mining industry in the US, we've had, I think, 11 so far. We've had 0. It's been a long time since that. But yeah, it's kind of like the mindset that we have, that we need to achieve that. And we're always striving towards to the 0 harm. And while we're doing well, I would say in terms of the number of accidents, we're still far from saying, hey, we still have 1 that, and we can bear with that.
Time for one more question, maybe? Okay.
Oh, oh, yep.
So, looking at your slide 12, the plot, if I were just eyeballing that and not using statistics, I would say it looks like your incident number went down. My question is, I've been in situations before where we did see a reduction in count, but our statistical analysis was such that we could not project a null hypothesis. And we were able to go back to management and say, well, based on the power analysis, we would need 18 months of data at this level to achieve any kind of statistical significance. So I'm wondering, in this analysis, were you able to do a power analysis to determine potentially whether you would need more data and even be able to come to a different conclusion?
We haven't done. I think it would be a good next step to do. Yeah.
All right, awesome. Thank you.